Good evening, everyone. Welcome to the fourth day of our session on programming in C language. So today we'll continue unit number 2. We have already studied variables, data types, constants, how to declare and initialize a variable, program stack, keywords, identifiers, scope, C libraries. Macros, we have seen how to use constant definitions for using macros. We have also seen how to use macros definition for functions. But once we study functions in C, at that time I will take this part again, macros. Then preprocessor directives we have seen, global and local static. This is our main topic for today, global, local and static variables. So we have seen variables. Variable is a memory location where you can store a particular value. You can declare a variable and then initialize it, or on a single line of code, you can initialize it as well as declare it. So last time we have seen these primitive data types. Today we will see one remaining data type, that is Boolean. Using a program, we will see how it works. So I'll just share my dev C++ IDE. So as you can see here, the first header file in the link section is stdio.h for standard input output. You can accept input from the user and print a message or any value to the output using scanf and printf respectively, which are defined in stdio.h. Now, if you want to use Boolean data types, like how we have int, char, float, double, that for Boolean data type, you have to write bool, bool. Now, in order to use this data type, you have to include one more header file, that is stdbool.h. stdbool.h. If you include this, then only you can use bool data type in C language. In C++, without including any special header file for Boolean data type, you can use it. But if you want to use Boolean data type in C language, you have to compulsorily include stdbool.h header file. Then what I'm doing here, I have one variable, I have second variable. So variable 1, its name is var1. Variable 2, its name is var2. So the first data type is of Boolean and it is storing the value true in the variable var1. The second data type is also Boolean and it stores the value false in var2. So first printf statement, what I'm doing, var1 is true and is equal to %d. Now %d if I give, what happens is the integer value corresponding to the Boolean data type will be displayed. Means if the Boolean data is true, then its corresponding integer value is 1. If Boolean data is false, then its corresponding integer value is 0. So %d, we can print the integer value of the Boolean data type. So %d, instead of that, what will come? Value of var1. Var1 is true. True in integer means 1. So what will come? Var1 is true and is equal to 1. Similarly, here the message will be printed var2 is false and is equal to 0. Have you understood this?
Yes.
What about others?
Yes, sir.
Yes.
Okay, now we'll run this program. Let us see what is the output. So see here, var1 is true and is equal to 1. var2 is false and is equal to 0. So we have got the correct output. Now suppose I make var1 false and var2 is also false. I'll change this also to false. Let's see whether 2 times we get 0 or not. See here, var1 is false and is equal to 0, var2 is false and is equal to 0. So our program is working correctly. Now our next topic after Boolean data type is so we have seen how much memory the each data type will occupy. We have seen difference between float and double. We have seen some examples of different data types, ASCII values, constants. We have seen keywords, identifier rules, program stack. Now today's topic is global, local and static variables. So now please pay attention. Global and static variables, these are the types of variables. It is not data type, it is just the type of the variable. Means global and static, both of them are initialized to 0 implicitly. Implicitly means automatically. Now suppose I say int a equal to 0. So the programmer or the user is writing 0 and he is initializing it to the variable a. If I'm saying int a equal to 0, the programmer is assigning the value 0 to a. But in global and static variables, the value assigned to these type of variables is 0 and the programmer is not doing it. Automatically, the compiler will initialize the global and static variables to 0. I repeat, global and static variables get initialized to 0 automatically. The programmer does not have to initialize the global and static variables to 0. The compiler will do it on its own. Next, global variables. These are the definitions of these three types. First is global variables. You can access the global variables throughout the program. Just a minute, someone wants to join. So in global variables, you can access that variable throughout your program. Means suppose you write a variable in one function, then it is not accessible in another function. But the global variables, if you write it in one function, you can access that same variable in another function. So suppose in function 1, I use the variable g. Without any problem, I can use that same variable g in another function also. And suppose in function 1, I write, I increase the value of g. Then in function 2, automatically the previous value of g. What is the previous value of g? The increased value. That value will be accessible. So we'll see it in a program. That time you'll understand it better. Now next is local variables. You can access them only from a particular scope or a particular function in your program. Within a function, whatever you write, it is local for that particular function. You take another function, whatever you write in that function is local only to that function. Means whatever you write inside a function, you can access it only in that particular function and no other function. These are the local variables. But global variables, in all the functions, you can access that particular global variable. Then static variables, you can access it only from a particular function or scope, but their lifetime is that of entire program. So we'll see static variables. It has a sort of mixed characteristics compared to global and local. We'll see it in our program. So first one, local variables. So the variables declared within a block. See, when I write a function, I enclose it within curly braces. So this particular thing is a block of code. So I've written block. So see now, look at the left-hand side. I've written main within and parenthesis. And within main, see this curly bracket. Within main, I'm writing int a comma b. And what I'm doing, I'm initializing a to 3. I repeat, main function, in that I've written int a comma b, a equal to 3. Okay, just keep this in mind. Now pay attention to what I'm speaking. When you want to execute a program, it has to be given some memory space. If it is not given any memory space in your computer memory, that program cannot get executed. So there are two types of memory broadly. One is RAM, which is known as primary memory or main memory, that is random access memory. And the other is your secondary storage memory, which is a permanent memory. Means permanently whatever you store in your secondary storage, it will get stored permanently. So what I mean by this, if RAM you are using, and then you write something, you write a program or you store something in your RAM memory, and once you switch off the power of your computer or your mobile, then whatever you have stored in RAM, that gets disappeared. It will no longer be available after you switch on your power again. So first I take a file, I write something in it, I store it in RAM, then I switch off the power of my device, then I switch on the power of my device and try to access that data it will not be available for you. It has disappeared. So this is called as volatile memory. Very easily you can lose it. But if you want to store something permanently means what? You write something, you store it in a secondary storage device, then you switch off the power, then you switch on the power again. After you switch on the power, you try to access that data. It is available. It has not disappeared. This is your secondary storage. So RAM is one type of memory, which is your main memory. And then you have secondary storage devices like your hard disk or your disk drives. They can store your data permanently. So that is the importance of secondary storage devices. Now, whenever you want to run your program or you want to execute your program, some memory has to be allocated to your program. So this memory is allocated to your program in the form of RAM, random access memory, means the memory which is not storing your content permanently. So RAM is given to your program. When RAM is given to your program, then it will get compiled, your program will get compiled. When your program gets compiled, what will happen? Your high level language instructions will get converted into zeros and ones, which is nothing but machine level language. Compiling means high level language is converted to machine level language. So when you compile your program, your code, program code or source code will get converted into zeros and ones. Now this zeros and ones is stored in another file. The entire program in the form of zeros and ones is stored in another file, and that particular file can be executed. Your C program file, which you have written in high level language, that cannot be executed directly. It is first converted into zeros and ones, stored in another file, and that file can be executed. Now this another file that I'm talking about, it is stored in your secondary storage devices, means in your permanent memory. It is not RAM. Whatever zeros and ones have been generated, that is stored in your secondary storage memory. And this file in which zeros and ones are stored, that file you can execute. And this file, it is called the intermediate code. So when you can execute this file, and the extension of this file is .exe. Your high level language file, its extension is .c. But your executable file, its extension is .exe. So you can execute your program from this executable file. So what happens? The memory that was allocated to your program, it is of a big chunk of RAM. It is not secondary storage, but your zeros and ones ka file, it is in secondary storage. So the memory which was allocated to your program, that memory is RAM, and it can be divided into number of divisions or segments. So that memory which was allocated to your program, it is divided into heap, stack, data or global segment, and code segment. These are different segments. So stack segment is where all your variables, functions, they will be given memory in the stack segment. Now below the stack segment, you have global and static segment. Here all the global and static variables can be stored. Below that you have your code segment. In your code segment, the actual instructions of your program will get stored. See, the instructions of your program also have to be given some memory, and your variables and functions also have to be given some memory. Have you understood this part till now?
Yes.
Yes.
Yes, sir.
Do you want me to repeat? Does anyone want me to repeat?
Can you repeat heap and stack?
Okay, so heap, now we'll see that little later in today's session only. But in stack, what we do? In stack, the memory is given to the functions and the variables. Your normal variables are the int a, or your normal function to add two numbers. All that is given memory in your stack. Means whenever you write a function, whenever you initialize a variable, memory will be given to that function or variable in the stack. So in stack, what will get stored? All your functions and variables. Then in global and static part, all your global and static variables will be given memory in this section. In data and global section, all your global and static variables will be given memory. and in your code segment, all the instructions of your program will be given some memory. Because if you don't give this memory, if you don't give them the memory, they will not be able to get stored on your computer. If they are not stored on your computer, how you will execute your program? So each and every part of a program needs to be given memory, and that particular memory which is given to your program is called applications memory. And within that applications memory, you have different divisions like stack, global static section, code section, heap section. Okay, is it clear now or should I repeat again?
Understood.
Okay, others, have you understood?
Yes.
Okay, so now memory is allocated to different parts of your program in these different segments. Now, you have written your program, you want to execute it. So what will happen? When you want to execute your program, whatever executable file was created, that is zeros and ones ka file, that file will be copied to your code segment. The last segment you can see here, this last segment. Here all your instructions which are in the form of zeros and ones in the executable file, that whole thing will get copied to your code segment. Now why it is done? All your zeros and ones, that file is copied to your code segment, and in code segment, which type of memory is available? Your RAM, random access memory. All the memory that is allocated to your program is in the form of RAM. So each section of the memory, like heap stack, each section also has RAM memory. So code also has RAM memory, and all your zeros and ones are copied from your executable file. Executable file is where? On your secondary storage device. From your permanent memory, the zeros and ones are copied to your RAM memory, where in the code section. Once that zeros and ones are copied to your code section, then your program will get executed finally, and you can see the output screen. I repeat, program is allocated RAM memory. That memory is divided into different sections or segments. Your program is converted into zeros and ones and stored on your secondary storage permanently. Those zeros and ones from your secondary device are copied to the code segment, which is having RAM memory. Once the zeros and ones are copied to your code segment, they can get executed. Is this clear?
Yes.
Yes.
What about others?
Yes, clear.
Okay.
Yes.
Okay. So this is just the theoretical part which every programmer should know. And C language can help you understand all these things. So now let's get back to local variables. You have your main function. In that you have int a comma b and a is equal to 3. Only concentrate on main function. Now, see here at the right hand side where the memory block I've shown, no, RAM memory. Look here. Consider this whole thing is your stack. This part. This square is there, no, this whole thing is your stack memory. So what will get stored here? Your functions and variables. So you can see here, I've written A and I've written B. So A and B variables are allocated memory, or they are given memory in the stack segment. A and B are given memory in the stack segment. So this is the first step. Why it is given in stack? Because A and B are variables. They will be given memory on the stack segment. Okay, now I want to initialize A and B. A I am assigning 3, B I am assigning 4. See here, A I have assigned 3 and B I have assigned 4 on the stack segment. Now, this was your main function. So in the stack segment also you have certain divisions. Why divisions? One division will be for main, second division will be for some other function, third division will be for some other function. Okay. So within the stack section, you have again some divisions, and those divisions are for your different functions in your program. So in the stack, you have different divisions. Each division is for a particular function in your program. And within the function, what you can have? You can have variables. So in the section created for each function within the stack, you will have your variables. Is this point clear? Within the stack also you can have sections for your different functions. Is it clear?
Yes.
Okay. So A and B is assigned 3 and 4, and that memory which is given to A and B, it is in the stack. Okay. Now what I'm doing next in main, I'm doing printf. I'm printing A and B. After I print A and B, what I'm doing, I'm calling another function within main, which is that function func. So as soon as this statement comes, func parenthesis or func brackets, as soon as this statement comes, what will happen? Next, what will get executed is the function func, which I've written here. You're calling the function func, so the statements of func will get executed. What are the statements of func? This int I, c, and printf. These are the statements of func. So what I'm doing now, I'm calling one more function. So memory has to get allocated to func. Where the memory will get allocated to func? Can you tell me in which segment?
A stack.
Yes, stack segment. Why? Because it is a function. Functions, variables, all will occupy the stack segment. So now I'm doing what? Int c. And then I'm doing c equal to 5. So what will happen? I've called the function func. So memory will get allocated to func. And when memory is allocated to func, memory will also be allocated to variable c. C is within func. So memory has to get allocated to c when you allocate memory to func. So see the next statement. C is equal to 5. That has occupied this space, and this block is for which function? func. Above block is for main. And each section within your stack, this whole thing is your stack. Each section within stack is called a stack frame. Okay. Someone wants to join. So each section within your stack is called a stack frame. And the whole thing is a stack or a stack segment. So main is allocated memory, func is allocated memory. Now what will happen? I finished executing the whole func. This whole thing I finished executing. So what will happen? From here, see what had happened. func was here. Then I went here to execute the statements of func. I finished executing the statements of func and I came back to my main function. Now main function also got over because after func, you don't have anything else, right? After func, you don't have anything else in your main. So main function also got over. Okay. So first func function, it got over. So memory has been removed for func. func was allocated memory here. That has disappeared. Why? Because func ka work is over. Similarly, all the variables or all the related to the statements of func, that is also erased now. And then finally, your main, whatever memory was allocated to main also, that will also get erased. Okay. Have you understood till this part?
Yes.
Yes.
Why it will be erased?
Yes.
Because the work of func is over. Okay.
Acha,
Once you
yeah.
call it in your main program, func ka statements will get executed. Once it is executed and over, memory will get removed for func. Means func will get deallocated. Is it okay?
Okay. Yeah.
Okay. So now what had happened? Within the stack, you had some part for your main and some part for func. Why these partitions are created? So that you cannot access the variables of main in func and you cannot access the variables of func from main. Means what? In main only you can have AB. That AB you cannot access from func. See what I mean is, see here in func, what all we have? We only have C variable. Do we have A and B in func? No, we don't have. But suppose we try to write A here, and if we print the value of A here, it will give an error. Why? Because A cannot be accessed from func. A can be accessed from main. In main, see, I'm writing printf A comma B. In main, you can access A and B. But in func, if I try to print the value of A, like this statement, if I write printf %d A, I cannot do that. It will give error because A is local to main. A is a local variable of main function. Similarly, C is a local variable of func function. So you cannot access A from func and C from main. it will give an error. Okay, so what I'm trying to do here, I'm trying to write okay, this is not here. If I try to write a equal to 8 here, what I'm doing, I'm initializing a over here. A equal to 8 I'm writing. This a is what I'm trying to refer to int a from main. I'm trying to access this a over here. So is this possible?
No.
No, yes, correct. You cannot access a of main from FUNC. So I'm trying to write a equal to 8 here. And then what is happening, since I'm calling FUNC, memory will get allocated to FUNC. So C equal to 5 is stored here and A equal to 8 is stored here. But this is wrong. You cannot do this. Okay. But suppose what you do, suppose you write int A over here. Now this A and this A are both different. If you write only A in FUNC, it will refer to which A? This A. If you write int A in FUNC, it is a new variable A in FUNC. This int A and this int A are different. So you can access this int A in FUNC and this int A in main. But you cannot access this int A in FUNC and this int A in main. Have you understood?
Yes.
Yes.
So what is happening? You have the same variables, A and A, in two different functions, but their meaning is different. They are not the same variable. So int A in FUNC is different, int A in main is different. So what will happen? You are writing int A in FUNC. When you call FUNC, memory will get allocated to FUNC. So in FUNC, which variables you have? C and A also. So C will be initialized to 5 and A will also be initialized to 5. Now if you write printf A comma C in FUNC, if you do printf for A and C in FUNC, you will get 5 and 8. But if you don't write int A equal to 8 in FUNC, that A is referring to main function ka A. So it will give you an error. But in FUNC, you have a different variable A, and that A is not the same A in FUNC. That is a different A. That A you can access from FUNC. So the A in main and the A in FUNC are local to main and FUNC respectively. So this is what the local variables. Have you understood till here?
Yes, sir.
Yes.
Yes.
Everyone please respond because this is very important. Have you understood?
Yes.
Yes, sir.
Okay. So now to get this concept clear, what we will do, as usual, we'll execute some program and see what is the output. So see here, local variable ka demo program this is. So as usual, hash include stdio.h. Then see here, your program execution will start from which function? Can you tell me?
Main.
Yes, main function. So what will happen? As you can see, int main, within curly braces, I've written the statements of main function. So in main, which variables I have? Int a comma b. A equal to 3, b equal to 5. What I am doing here? Printf inside main, a is equal to and b is equal to. So by this print function, what will be my message on the output screen? Can anyone tell me?
3 and 5.
Yes, very
inside
good.
main.
Yes, correct, correct. So a equal to 3, b equal to 5. You know percentage we are using, what happens and all that. So this part I've commented. We'll just see this. What is this? For now, you only remember int a equal to 3, b equal to 5, and I'm trying to print a and b ka values over here. So I will run this program. Let's see what happens. As one of you gave the answer, inside main, a equal to 3, b equal to 5. So this is working well. Now, what I'm doing, I'm removing the comment here. I'm calling a function with the name FUNC. So as soon as this statement, whenever it is the turn to execute this statement, See how your program will get executed. First int AB gets executed. Then A is equal to 3, B is equal to 5. This happens. Then your printf will get displayed. And then your func will get called. So whenever your func function is getting called, what will happen? The control of your program will jump to the body of func. This is called as function declaration. Sorry, function call. Okay, this is called calling a function. Once this function is called, the control of your program will jump wherever the statements of func are. So whenever the control goes to func, the statements of func will get executed. Whenever the statements of func get executed, first what will come? Int c equal to 6. This will get executed. Then what will get executed? Printf inside function c is equal to 6. Okay. Have you understood this?
Yes.
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 Okay. Now I'll run this program. Let's see what happens. See here, we are getting the expected output. First, what will happen? Inside main a equal to 3, b equal to 5. That I have not changed. What I have changed is I'm calling one more function inside main. What is that? Inside function c equal to 6. So everything is correct till here. Now what I'm doing? So after I hit this statement, this is the comment. After hitting this statement, the control will go where? Since the statements of func are over, the control will go back to this line. And after this line, whatever statements are there, that will get executed. Have you understood this?
Yes.
Okay,
Yes.
very good. Now what will happen? I'm removing the comment from this line also. So inside your func function, what you had? You had a variable c. That c variable I'm trying to access here. How I'm trying to access? I'm trying to access c variable by trying to print its value at the output. So here I've not done int c separately. Since I've not done int c separately, what happens? I'm trying to tell the compiler this c and this c are same. I'm trying to tell the compiler that this c within func and this c within main are same. But that is not allowed. Still, I'm trying to do it. So let's see what happens. See, I'm getting an error. What is the error? C undeclared. C undeclared means what? Int C is missing. Okay. So which statement is missing? This statement, int C. This statement is missing. Okay. So this is an error. Now what I'm doing, I will write here int C and I'll say C equal to 10. Okay. So what will happen? This C within main and this C within func are different. So what will happen? When I try to print C ka value from this statement, what will come? Inside main C equal to 10. Why 10? Because here I've done int C equal to 10. This C and this C are different. So 10 will come here. Let's see when I run what happens. See, error has gone. And what has happened? Inside function C equal to 6 and inside main C equal to 10. Okay, now I'll put a new line character here, \n. Why I'm doing that? So that each statement comes on a different line at the output so that you can see the output properly. See, 3 statements are there. They have come on separate lines. So first is what? Inside main a equal to 3, b equal to 5. Then is what? The function call. From there, what I'm printing? The value of c, which is within the function. So c equal to 6. Then what I'm doing? I'm coming back to main. In main, what I've done? Int c equal to 10. That c ka value is getting printed here. So you see function wala c and main wala c are different. Have you understood this?
Yes.
Has everyone understood
Yeah.
or should I repeat?
Yeah.
Should I repeat?
No, understood.
No, understood.
Okay. So when you, after this session, means we'll continue now, but after 6:30, you have to practice these programs. Unless you practice, you won't be able to understand what all I'm telling. Okay, now what we tried to do, we tried to, I'll remove this int c so that again I get an error. Now, we are trying to access C from func within main, not allowed. Suppose I try to access A and B in FUNC, will it be allowed? Can you answer my question? If I try to access A and B within main, within FUNC, from FUNC, can I access A and B?
No.
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 Yes, very good. Your answer is correct. You cannot access A and B. So what we'll do, I'll remove this statement from main so that we get an error only over here. So what I'm trying to do in FUNC, I'm trying to access A and B. We will definitely get an error, as you can see here. See, a B is undeclared, A is undeclared. If I do int AB, A equal to something, B equal to something, then this will not give any error. So you can try that at home. Have you understood local variables?
Yes.
Yes.
Okay, very good. If any one of you has come late, they may not understand what is this. So you can either ask me in the next lecture, or you can ask your friends how to do it, or you can ask me only in the next lecture. So now we have finished local variables. Now what we will see is global variables. So see here, this is the first example. We'll go for a simpler example first. So see here, global variables. These variables can be accessed throughout your program. All functions can access. They are declared outside the function block. What do I mean by this? See, first you'll write here what? Hash include. After hash include, if you remember program structure, after hash include what comes? Your constants. And after your constant what comes? Global declarations. So there I had said no global declaration. That means global variables are being declared after your hash defined statement. So how they're declared? What is declaration? Int variable name. So what I've done here, int g. And within main function, I'm going to access this g variable. So as you know, we have our stack segment. Your program will start execution from main. So main will get allocated some memory on your stack. The memory space or the section which is allocated to main, what it is called? Stack. What it is called? Stack.
Stack
Stack
segment.
frame.
Yes.
Stack frame.
Yes, stack frame is what I expected. Each section within stack is called a stack frame. If you combine all the stack frames, what you'll get? Stack segment. If you divide your stack segment, what you'll get? Stack frame. If you combine your stack frames, you'll get stack segment. So stack frame will be allocated to main. Now, next slide. Within main, I'm trying to access G. So as you know, if I had within main, if I have int A, within main I have int A. So in main, I'll get A over here. Okay, within main. If I say int A equal to 5, semicolon, then this A within main will get initialized to 5. But as you know, after the work of main function is done, what will happen? Deallocation of memory. Means main will disappear from the stack. So what will happen? You cannot access the variables of main any longer. But since the global variables can be accessed by all the functions, these global variables have to remain in the stack permanently. But this is not possible. As soon as the work of the function is over, memory will be removed from it. So all the variables within that function, they'll also disappear. But we don't want that. Why? Because if one function is over, then the second function may also need that global variable. But if it is declared within some function, if the global variable is declared within some function, then it will disappear from that function. And then the other functions cannot access it. But if you declare the global variable above or outside all the functions will be able to access int g. So int g has to be stored in a special place. It cannot be stored in the stack. I repeat, global variables cannot be stored in the stack. So where they'll be stored? I have told you, below stack you have global or static segment. within the global or static segment, you can store your global or static variables. So now we are seeing global variables. So int g, where it will get stored? Can you tell me which segment?
Global static segment.
Yes, very correct. So in your global and static segment, your int g will be stored so that it can be accessed by all the functions. So what happens? Here you have g. And I've told you in the theory part, global and static variables are initialized to 0 as soon as they're declared. Means if the programmer does not initialize it, what is the value initialized to g? 0. Immediately after declaration, 0 is assigned to g. So g equal to 0 will happen in your data segment. But the programmer can change the value of g after it is means anywhere in the program. Means what you can do, above all your functions you can write int g. Compiler will initialize it to 0. Suppose you don't want it to get initialized to 0, what you'll do, you yourself will initialize it to some value like 10, 20, whatever. So in that case, what will happen? G will not become 0. G will be stored as 10 in the global static section. Okay, so as I said, whenever you have int g in your global section, g will be 0, it will be initialized. But then suppose I want to initialize it to 10, then within your data segment or global segment or stack segment, all mean the same, g will be initialized to 10. Now, as I said, g can be accessed by all functions. So I've written int g equal to 10. So main can access g, func1 can access g, func2 can access g. Okay. Now suppose in the main function, I change the value of g. Change the value of g means what? I reinitialize it. I again initialize it to some other value 20. Okay. G equal to 10 is done already. Now main function is getting executed. Within the main, if I initialize it to 20, everywhere throughout your program, g will become 20. G equal to 10, that was there, no? That gets cancelled. And within your global segment, g equal to 20 will get stored. G equal to 10 will go away, g equal to 20 will get stored. Okay, this is called reinitialization or updation of the value of the variable. Now g is equal to 20. So if from func1, if I'm trying to access g, what will be the value of g? Can you tell me?
0.
20.
20. Why will it be 0? Only in the beginning.
10.
Yeah,
10.
only in the beginning, if you are not initializing, it will be initialized to 0. But now what I've done, I have initialized it to 10. After doing that in main, what I've done, I've initialized it to 20. So throughout your program, g equal to 0, g equal to 10 is gone forever. Now what is existing? G equal to 20 is existing throughout your program. So from func1, if I want to access g, what will be the value of g? Can you tell me? Can you tell me?
Please repeat the question.
We have done g equal to 10, then I've done g equal to 20 within main. So now what is existing? G equal to 20 is existing. So from
Yes.
any other function, if I want to access g, what will be the value of g?
20.
20.
Yes, 20.
20.
Correct. Now what I'm doing, within your func function, what is the value of g? 20. Now within func function, if I write g equal to 30, what will be the value of g now throughout your program?
30.
Yes,
30.
correct. 30. So suppose from function 2, I want to access g. What will be the value of g?
30.
Yes, very good. Within function 2, if I write g equal to 10, what will be the value of g now?
10.
10.
Yes, perfect. Very good. So this is what happens, that g variable is shared by all the functions. Suppose in main function you are doing something to g, it will get reflected for all your functions throughout your program. Why? Because it is a global variable. Have you understood global variables?
Yes.
Very
Yes.
good.
Yes.
Now what we will do, as usual, we will execute a program to demonstrate global functions. If you are joining this session late, you will definitely not understand what I've done. So what you have to do, either in the next session you ask me your doubts, or you clarify it from your friends. So it's better always to join the session from the beginning, because each thing is linked to each other. So see here, now demo program for global variables. So what I'm doing in my main, printf global inside main. Means what? What is the value of global variable inside main? So what I've done, hash include stdio.h, and then as usual what I have to do, int g. So here what is g initialized to by the compiler?
0.
0.
Yes, very good. G is 0. So throughout your program, the value of g is 0. So that's what I want to print over here. Within main, I'm accessing g. So let's see when I run this program, what is the value of g. So as you can see, I was speaking the truth, g is equal to 0. So why I show you programs, so that you can see that what I'm teaching is actually the right thing. So g is equal to 0 within main. Okay. Now what I'm doing int g equal to 30. Okay, sorry, don't see this. I'm doing g equal to g will be 0. Now what I'm doing, before this print statement, I'm calling one function func. So what will happen? Execution of program starts from main. So first statement within main is what? You're calling some function. So immediately the control will jump to the definition of func. You have called func in your main, but you have defined func outside your main. Okay, you can call your functions within main, but you have to define them outside main. Calling within main, defining outside main. So this will get more clear when we study functions actually in C language. For now, you have to keep these points in mind. So within func, let me access the variable g. So here, within func, what will be the value of g?
0.
Yes, very correct. Let me run this program. So see here, within inside function, g is 0, and inside main also g is 0. Very good. We have understood this.
But why
Now what
0?
because it is automatically
Yeah, yeah,
initialized to
yeah.
0, right?
It has been
Okay.
commented, yes.
Yeah. So don't pay attention to all this thing. Only what is not commented, you pay attention.
Hmm.
Yeah. So now g is 0 throughout your program. Now what I'm doing, this comment, the first line I'm removing, I'm saying g equal to 20. So this g and your global g both are same. And I'm reinitializing the global g to 20. So now everywhere, what is the value of g?
20.
20.
Yes, very good. So let me run this program again. So as you can see here, within function, inside function g is 20, inside main also g is 20. We have understood this. Now see here, I'm writing one more line. Int g equal to 10. Now int g and your global g, are they same?
Yes.
No, they are not
No.
same.
No,
No.
not
Yeah,
same.
yeah.
It's local
Int g,
variable.
yes, this int g what I've written, it is a local variable for func. And this top int g what I've written, it is global variable for your program. This int g is different, this int g is different. So this top int g and this g equal to 20, that was same. But this top int g and this inside int g, they both are different. So what I've written, g is local and it is initialized to 10. So this is any normal variable, which is a local variable. The top int g is global variable. This g is used to access that global variable, and this g is a local variable for func. This g is local for which function? func function. So what I'm doing now, I'll run this program again. So as you can see, this int g top wala is for global, that is maintained, and inside main also maintained. But now what I'm going to do, I'm going to do int g equal to 10, and then I'm going to print the value of local G. Local G ka value I'm printing. Okay. So it is not global. So what will be the value of local G?
10.
10.
Yes, correct. So 10 will come in your inside function. Sorry. This one, there should not be any ampersand symbol there. Otherwise it will give the address of local G. So what is this now? This inside function, this statement is coming from what? This statement. 1 minute. See here, this globe, this is referring to this line, and this is referring to this line, second line. So this is global G, first line, and this is local G. So first line is coming from here, second line is coming from here, and third line is what? Coming from your main. Okay. And in your main, G ka value is what? Global G, that is 20. Local value is 10. Local for which function? FUNC function. Inside FUNC function, the local value of G is 10. But inside main, I cannot access that local G. I can access only global G. Why I cannot access local G in main? Because local G is local for FUNC. You can access local G only within FUNC. You cannot access local G of FUNC within main. So now what I'm doing, have you understood till here?
Yes.
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 Everyone has understood?
Yes.
Yes.
Very good. So now what I've done, there is one global variable. I've made it 20. Then I've made a local variable. I've initialized it to 10. And now if I write G equal to 30 over here. So is this global or local, we want to know. See, this is global, this much part, this much is local. So now if I'm writing G, I want to know whether it is global or local. So how can we know that? I will tell you. This G, we are in doubt whether it is global G or local G. So let me tell you, this G is local G. Why? As soon as you create any local variable G, only that you can execute after writing int G. So here I'm writing int G equal to 10. This is local. And after that, if I access G within FUNC, all that G is local only. You no longer can access global G within FUNC now. Before int G equal to 10, you can access global G. But as soon as int G equal to 10 comes, you cannot access the global G. All this will become local G only now. Have you understood?
Yes.
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 Okay. So this is local or global G? Can you tell me?
Local.
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 Yes, very
Local.
good. Yes. Now I'll try to print the value of local G. So let's see what happens. So see here. First, what is called main. Within main, what is called FUNC. Within FUNC, what happens? I'm assigning 20 to global G. So from this statement, what should happen? G ka value should be 20. See the first line, G value is 20. Okay. Now this is local G. Its value should be what? 10. So as you can see, second statement value is 10. 1 second. One minute. See here, in your first line, it is global G. The value is what? 20, as you can see. This is your local G. Value has to be 10. It cannot be 20. So value is 10. And then this is again your local. Means here your local is value 10. And here your local G, you are reinitializing it to 30. all this is local. This is your first initialization of local variable. This is your second initialization of local variable. So what is its value? It has to be 30. And inside main, I cannot access local variables of FUNC. So inside main, your global data value, which is 20, that only you can access. Have you understood till here? Local and global variables, have everyone understood it perfectly?
Yes.
Yes.
Do you want me to repeat? Has everyone understood?
Yes, sir.
Yes, sir.
Yes.
Yes.
Okay. Now, one last topic and then we'll finish. In this PPT, I have given one more example of global. If you want, you can go through it, or in the next session, I will explain. Now, next topic is static variables. So static variables have certain characteristics of global and certain characteristics of what? Local. So your static variables are initialized only once. Means what? I'll tell you. Okay, we'll see it through a program first so that you can understand it. So in dev C++, I've written a program for static variables. See here, your main function, inside main, this message will get displayed. Then what I'm doing, I'm calling FUNC. I'm calling FUNC function. So when I call FUNC function, int a equal to 8. A is local or global variable, can you tell me?
Local.
Yes, very good. A is local and I'm assigning 10 to that local A. Sorry, 8 I'm assigning to local A. And then I'm printing the value of A. So what value of A will get printed?
8.
8.
Yes. So I'm running this program and as you can see, value of A is 8. Now what I'm doing, I'm calling that same function again. FUNC I'm giving twice, means twice the same function will get executed. So what will happen? 2 times 8, as you can see, twice 8 has appeared. Now, if I call a third time FUNC, how many times 8 will get displayed at the output?
3 times.
3.
3 times.
Very good, 3 times. Now, so 8, 8, 8 will be the answer. But suppose I want the value 8 to get increased each time I am calling FUNC. So what I do, A is equal to A plus 1 means what I'm doing, I'm storing the value A plus 1 within A. This is called assignment. A plus 1, that value is getting stored in A. So what happens, int A equal to 8, and then which value A is storing? The value 9. Why 9? Because in A, what is getting stored? 8 plus 1 is getting stored in this. So what value will get printed from this statement? Can you tell me?
9.
9.
Very good, 9 will get printed. So now, what will happen? Will I get 3 times 9? Do you agree with me?
9, 10, 11.
Okay, so you're saying 9, 10, 11. So let's see what happens now. So actually you're getting 3 times 9. Now why you're getting 3 times 9, I will tell you. See, I'm in main function first, main will get executed. Then what will get executed? Inside main, this statement will appear. Then what will happen? FUNC, you're calling. So when you're calling FUNC for the first time, what is happening? Int A equal to 8. And then A is equal to A plus 1. So till here, you're getting the value 9. Now the work of FUNC is over. Then I'm calling FUNC a second time. So what will happen? Int A equal to 8. Again, A is getting 8 value. Okay. And then again, you're making it 9. And then here you're getting 9. The work of second time calling is over. Now third time I'm calling FUNC. Again, A is becoming 8. Again, A is becoming 9 and you're printing 9. So that is why you're getting 3 times 9. Is it understood by all?
Yes.
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 Okay. So now I don't want this. As someone told me, you want 8, 9, 10. Sorry, you want 9, 10, 11. Since you want 9, 10, 11, you have to make A as a static variable. So how to make A? This is a normal local variable, but you want to make it static. So I'll write static. This is a keyword. Static is one of the keywords within C language, C++, Java language. When I make it static int a equal to 8, you will get 9, 10, 11. Why you will get 9, 10, 11? Because once you call func, a is becoming 8, a is becoming 9, you are storing 9. Second time when you call func, this first line is there, no, that will get ignored by the compiler. Means what will happen? A equal to 8, that statement will not get executed. So currently what is the value of a is equal to 9. And then 9 is becoming 10 using the second statement. And then 10 you're printing. Then what you're doing? You're calling third time. So here, what is the value of a now? It is 10. This because this line is ignored. A is 10, you're making it 11, and you're printing 11. Is it understood?
Yes.
Yes.
Okay, so now I'll run the program, and now you can get 9, 10, 11. Okay, so what was the error? You had a local variable a, and that was again and again getting initialized to 8, and that value was getting printed. But I've made it static, so that initialization or reinitialization will be ignored. Only once initialization will be done. Second, third, up to infinity times, the initialization will be ignored throughout your program. Is it clear?
Yes.
Yes.
Has everyone understood?
Yes.
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 Okay, very good. So now how it actually happens in memory, I will tell you, and then we can stop. So within func, I'm writing int a. So func is a function. Where it will be allocated memory, can you tell me?
Stack segment.
Very good, very correct. Within stack. Who has answered this question?
Ankit.
Very good, Ankit. So func will be allocated here. Memory for func will be within stack segment. And a also will be allocated memory within stack segment. So this stack frame is there, no? It is for which function? Can you tell me? For func function. This top stack fragment or frame is for main. This is for main. This is for func. Have you understood?
Yes.
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 Okay. So A is given memory in stack segment. But what happens as soon as you call func for the first time, it will get memory. As soon as the work of func is over, it will get erased, right? Okay, from here A will go, func will go. Why? Because in stack segment, once the work is over, the memory allocated to the function disappears. Am I right?
Yes.
Yes.
Yeah. So what will happen? Reinitialization will happen. Again, A will become 8. Why A will become 8? Second time when you call func, again func will get allocated memory here. Then when the work of second time calling is over, again this will get erased. Third time when you call func, again it will get allocated memory. Once its work is over, again it will get erased. Have you understood?
Yes.
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 So again and again A is becoming 8. So to prevent that, what I'm doing, I'm adding the static keyword. So I have to write static int a. Now static variables are not stored in stack segment. They are stored in static or global segment. So what we understand by this, a static variable is global within the function. Understood? Your global variable is global throughout your program. For your entire program, you can access the global variable. Means your global variable is available throughout your program. But your static variable is a global variable for that particular function in which you are defining that static variable. Static variable A is being defined within func, so it is global for func. Means only one variable A is maintained for func, and that same variable we are reinitializing, so that A cannot be stored on stack, and A has to be stored where? In your data or global or static segment. That is this segment. This is meant for global and static variables. So A equal to 0 will be permanent over here until the execution of a program stops. So A will be here within first, just a minute. So A is equal to 0. static variables are also initialized to 0 if you do not initialize them. So here I've not initialized. Is this declaration or initialization? Can you tell me this particular statement? Is it initialization or declaration?
Declaration.
Declaration.
Very good, declaration. So yeah, implicitly means automatically. Implicitly means automatically the compiler will assign it 0, and that will get stored where? In your stack segment. So throughout FUNC, the value of A is what? 0. Now if here I'm doing A plus 1, then what will be the value of A? It will become 1. 0 will go and A will be 1. Then third time you are doing FUNC or calling, then what will happen? 1 will become 2 using A plus 1. 1 has become 2, so 1 will go from here and 2 will come here. So now what is the value of A throughout FUNC? Is it 1 or 2?
2.
Yes, perfect. It is 2. So this is how global and static variables have to be stored not in the stack segment. They have to be stored in another segment, which is called as data or global or static segment. So that variable will get stored in that stack segment, that data segment, in that part of your memory, so that permanently throughout your program it is maintained. So only we have told the lifetime. How long is variable A alive? It is alive throughout your program, but you can access that A only within your function. You cannot access this A variable from main, but you can access it from FUNC. But that variable did not die. It is still alive throughout your program. Only thing, you cannot access it from other functions. It is alive. It is not dead. Once the function work is over, the memory is deallocated. No, it is preserved throughout your program. It is alive, but you can access it only from FUNC. Have you understood this part?
Yes.
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 Yes. So now, one more thing I want to show you here. This is the same program for static. If I write here int a equal to 12, which type of variable is this? Local, global, static? Can you tell me?
Local.
Local.
Yes. It is local for main, or is it local for FUNC?
Local for
FUNC.
main.
Local for main. This A I'm talking about. This A is
Okay,
local
okay.
for
Yes, yes.
FUNC. This A is local for main. Okay. So now this is a local variable. If I try to print the value of this, I will get 12. I will not get 8. Okay. Because only this A is accessible from main. This A is not accessible. Similarly, this A equal to 12 cannot be accessed from FUNC. Do you agree with me?
Yes.
Yes.
Yes. Excellent.
Excuse
So,
me.
yes.
Yeah, A equals to 12 is global variable, no?
No, it is local for main. You cannot access this A anywhere else in your program.
Hmm.
Have you understood, or should I repeat?
No, but how is it local?
See, I have not used, if I write global, where I have to write it? I have to write int A over here, right? Above all your functions. Then it becomes
Yes.
global. Do you agree?
Ah, yes.
Yes.
So I'm not writing it here now. Am I using static int A? Am I using it here? No, I'm not using. I'm simply writing int A. So when you simply write, it is just a normal variable. All this time in our sessions, we are all using local variables only. So it is a local variable for main function. If you try to access A here, the value of A is 8. If you try to access A here, value is 12. Have you understood?
Yes.
Are you sure you have understood?
Yes, yes, understood.
Okay, okay.
So for
So,
initializing global, so we have to initialize before the function.
yes, above all your
Outside the
functions.
memory.
Yes, outside all your functions, you have
Yeah.
to initialize. If you don't initialize,
Yes.
what is the default value of the global variable?
0.
Yes, 0. And if you do not initialize static, see, I'm not initializing static here. I will run the program. So what will happen? What will be the output? Can anyone guess it?
0.
0.
0.
Yes, it will be 0. Okay, now 0 I have. From this statement, it will become 1. Then this statement, again, when I call function, it will be 2. Again, if I call, it will be 3. So let us execute this program. As you can see, we have got 1, 2, 3. So to prove that initially the value of a is 0, what I will do, I will print the value here and I'll comment this line so that you know that a is 0 over here. So see, first it was 0, then it became 1, then it became 2. Is it clear?
Yes.
Yes.
Okay. So with this, we have finished our unit number 2. We have studied all the concepts. Do you have any doubts in unit number 2? See, I'll show you what all we have studied up till now. We have studied all this till now. In 3 lectures, that is 3 hours, we have studied this much. Do you have any doubt in this?
No.
No.
Okay. So now, I'm going to give you a first assignment for this course, and it will be graded, means how much you score in this will contribute to your final score by the end of this course. And maximum marks of this assignment is 20 marks. You have to submit it before 19 March. It is a Google form. It is like a big mega quiz. So the link of this quiz or this assignment is this. I'll put the link in the chat box. Okay, so just preserve this link. There are 20 questions, as you can see here. 20 questions, you have to answer them based on unit 1 and 2. Make a note of this link. Don't lose it. And start putting your attendance in the chat box. If anyone has a doubt, you can ask me now. If you have not put your attendance, put it in the chat box. And I want name, roll number, as well as class. Don't only put your roll number. Name, roll number, and class. And one more thing I want to tell you, only those who put their attendance here, only their attendance is marked. Suppose you forget putting your attendance, you will be marked absent for this session. Why I'm saying like this? Because this shows that you're alert to what I'm telling you. If you don't put your attendance, means you've just joined the meeting and you're not paying attention. So I'm telling you to put your attendance here. If you don't put, you're marked absent. Is there any doubt? You can still ask me.
Can you quickly tell about macros?
Okay, macros. Have you understood how to define constants using macros?
Yes.
Okay, only that much is included in the quiz. For
Okay.
function using macros, that we will see when we study functions. Okay?
Okay.
Yes. So don't pay attention to macros functions for now. Only macros constants you can learn. Any other
Okay.
doubt?
No.
Yes. Okay. Anyone else has doubt?
Are static variable only limited to one function, or we can
Yes, they are
use
limited
it
to
in
only one
another
function. No. Static int a, that you cannot access in your main. You can only access in FUNC.
If we create another FUNC2, can we access
Yes.
it there?
No, there also you cannot access. Only in FUNC1, the static variable of FUNC1 you can access.
Okay.
Okay? Any other doubt? See, static variables are global for the function in which they are defined. Any other doubt? Okay, if you don't have any doubt, then you can leave this meeting and you have to attempt your quiz and submit it before the deadline. What is the deadline? 19th March. Thank you for attending today's session.
Thank you, Bhaiya.
Thank you.
Welcome.
Thank you.
Welcome.